Okay, so I wasn't planning on standing next to the podium, so I'll still try to keep close. Cybersecurity and functional safety. How can two walk together except they be agreed? Amos 3:3. Hello, everyone. I'm Aviv Barkai. I'm with Intel, and this is my talk for ICHSA 2021. So, first of all, disclaimer, of course, thoughts and opinions expressed in this presentation are my own. They do not necessarily reflect the those of Intel or any other former employer. Sorry. So, with that out of the way, we can get on with it. Okay, so agenda. First of all, I'll explain about the topic that I'm talking about today. Then I'll be explaining what is reliability, what is functional safety. After that, I'll talk about cybersecurity. I'll compare security, cybersecurity, and functional safety. I will look at alignment between the two, and then a conclusion. Okay, so first of all, who am I and why this topic? Well, I'm a hardware and systems guy, and I've been multiple positions doing different things in Intel for a long time, and even before Intel. And several years ago, I started working on functional safety, and I was diving deep into it, trying to understand the mindset and not just the numbers or the definitions in the standard. And what happens is that 2 years ago, I moved to cybersecurity. And what I found out that the more work I did on cybersecurity, the more I saw that it seemed quite a bit like safety. And in some languages, such as Hebrew, Betichut, and German, Sicherheit, this is just one word that denotes both security and safety. Of course, there are differences, and what I will do today is share with you my observations on similarities and differences and where I think we should be. Okay, so let's understand what are reliability and functional safety. I assume the audience here is less familiar with it, so for the purpose of this discussion, I'm going to be using both terms interchangeably. And the definition of functional safety is freedom from unacceptable risk, meaning that some risk may be acceptable, of physical injury or damage to the health of people. It's not talking about money. And in the face of malfunction and physical degradation, and for those of you who come from the software world, the physical world degrades all the time. A system or function a system should function according to the spec, and there should be a high uptime, meaning the system should be available as much as possible. Now, in this talk, I'm aiming for the purpose of reliability and the purpose of safety, not just the dry numbers or the very distinct definitions in the standards, even though I'm using them, of course, during my presentation. Okay, so in reliability and functional safety, we define error rates per hour, and we talk about statistical error. So in 1 hour of operation, or take a billion-hour operation, we put all the systems one next to the other, and we ask ourselves, after 1 hour of operation, there's no malicious intent. Some of the systems are not going to produce a correct result. There will be a faulty result, or the system will fail. How many? And this is these are statistical errors, and the errors, the failure causes are diverse, mostly cosmic radiation, electromigration, and other causes in the physical world. Smaller transistor gates may be more susceptible to cosmic radiation or to different radiation effects. There are also systematic errors or failures, which is what we tend to call bugs, bugs in the architecture, wrong definitions, not enough validation. We didn't find that there was a problem. And when you look at where reliability and safety are going, so as consumers, and I'm sure you're aware of this, when you buy something, you expect it to work. So we increasingly expect to get higher level of operation, and we want to see more safety for the products we use every year. We buy a new device, it should be safe. At the industrial level, demand for availability goes higher and higher. If you look at a tier 4 data center with 99.995% availability, that means it's 26.30 minutes of downtime per year. And if you ask data center managers and companies who operate data centers, they'll tell you even that is way too much for them. Every year we have less patients for malfunctions and for anything that's keeping us and delaying us. Okay, now let's go back to cybersecurity. So when we look at cybersecurity, for the purpose of this discussion, I'll be saying security, meaning cybersecurity, and as opposed to reliability and safety, as all of us know, security aims to protect against malicious failures. Now, it's not practical to define a rate of malicious failures per hour, of course, and setting aside the cause and the malicious versus non-malicious, this isn't so far from safety. Let's look at some similarities. Okay, so the goal, keep the system running correctly. The overhead challenge, both security and safety have to keep their own overheads acceptable. And I'm not defining what is acceptable because that changes, of course, from system to system. And we try to detect in both disciplines that something's wrong so that we can do something about it. If you look at defense in depth, which is a classic security approach, in defense in depth, we never assume that one defense is enough. So in the medieval castle, we have a moat, a bridge, gate and walls, guards on the walls, inner walls, and so on. Does this work for safety? Well, you'll be happy to hear that this is great for safety, because in safety, the safety approach is to have multiple safety mechanisms. As much as possible, they should be diverse. CIA. Now, some of the historical security is concerned with CIA, confidentiality, integrity, and availability. Now, I know that some of you are thinking, hey, there are other pillars, there are other terms, and there are alternative terms defined by different groups, such as authenticity, non-repudiation, privacy. And safety is also concerned with integrity and availability. Integrity of the data is super important for safety. And of course, availability of the system or the function is at the heart of safety as well. Confidentiality and privacy are outside the direct scope of safety and reliability based on how industry standards define them today. Maybe we need a new definition, but that's how all the standards define it today. If we look at the future trends, we started talking about this, we know for safety, the future is less errors per hour and higher safety and reliability. I'm sure you all know what is the trend for security, and unfortunately, it is more attackers and more attacks. Now, let's do a look at the table comparison between safety and security. So, failure cause for safety and security, the natural world for safety, it's natural world for security, it's malicious actors. The type of threat or hazard is the underlying physics, which essentially remain the same. Sure, we're using different technologies, but the physical world looks the same. For security, we are seeing new attacks, new attack vectors, as well as the old attacks and the older attack vectors. For mindset, we're seeing statistical, organized mindset in safety, and in security, existing, emerging threats. The trend for safety and reliability is higher reliability. The trend for security is more threat actors, unfortunately, and I think we all hear about that. Now, this is something a little strange, but in my experience, the ambiance or the vibe for safety is typically boring and just too many documents. while for security, it's cool, mysterious, and out of the box. Regarding the pillars, it's CIA minus the C, minus the confidentiality and safety. And of course, it's all of these in security. And when we look at defense in depth, it's great for both. It's a classic for security, and it's great for safety. Let's start thinking about possible alignment here. Now, there are standard work groups who are looking at alignment. One of them is IEEE P2851, which is looking at having a single language for safety analysis and extend it to have the same language in security analysis. Another one is if you look at the cybersecurity for road vehicles, that's ISO 21434. It is just in 28 times. Go look at what the safety guys are doing or consider safety violations as a cybersecurity attack. That's a lot of pointers towards the safety direction or getting inputs from safety people. There are academic papers suggesting joint or unified framework, such as the Sahara for threat and risk analysis or a single development life cycle. But you know what? I don't think we're seeing a unified approach yet. And if you look at what's happening in the industry, I think we're seeing that if I'm looking at offerings from some of the leading testing and training companies, some of them are advocating this, and you can find them on their web pages. Advocacy for aligning and combining security and safety, where applicable. But I don't think anyone can find a training that says, here's how you do both together concurrently in a joint mindset. Where we are now is in the industry, we're seeing separate work which converges if there's a product, it converges at some project milestones. If we're looking at the academic world, very few works on this topic, and I'm talking about what we see published. And I think that researchers tend to stay in their own domain. They attend their own domain's conferences, such as this one. And this is the natural way that we do things, I think, at least up until today. My call for action to you is let's spend some time in each other's domain. Security people, all of you in the audience and on Zoom, what do we have to learn from safety mechanisms? For example, diversity in function, doing the same thing in different ways and comparing the result to see that it actually got there. We agree on what to do now, whether there's a threat or not. Safety people, what do we have to learn from security monitoring? Maybe non-repudiation is a good way to achieve integrity. So security folks think and learn safety, and safety folks think and learn security. Break the boundaries between the disciplines and the community, at least as much as possible, and where applicable. Where should we go from here? Well, I think we need to go to more safety and security features, alignment, and joint work and joint structured work. Structure isn't a curse. We should, or this is everyone's goal. This should be the goal of researchers, engineers, developers, managers, program managers. Let's build together a safe and secure world. Thank you.